All right, welcome. Welcome to yet another episode of TGI Kubernetes. This is episode 21. I'm excited. I feel like we're getting into the swing of things for the new year, so that's exciting. If folks could give me a quick sound check, a thumbs up, you can hear me. Hey, Kevin, how's it going? You're saying good morning. I'm wondering where you're at, where it's morning there. So, Hans from Sweden, Sudeep, good to see you. So Kevin, I'm guessing that you're all the way, it's like Saturday morning for you. That would probably be the thing. Or maybe you're in Hawaii, I'm not sure. Something like that. But anyways, Robert, good to see you. You're going to answer all my questions here as I get confused on this. Good to see you. Okay, Ravi. Yeah, Bismarck, Suresh, Kevin. Oh, you're in Australia. Yeah, Rodrigo. Yeah, in the future. So, Dave Cheney's working for us in Australia. And he used that joke that he's living in the future. And my retort was, I would have thought that the future had better internet access. And he's like, ouch. Hits a little too close to home. Colm, Abraham, nice to see y'all. All right, Steve-O. Good to see you. All right. So the topic for today, well, first of all, I'm Joe Beda. I'm your host here at TGI Kubernetes. I'm one of the... Osman, nice to see you. I'm sure I'm butchering your name. I apologize. I'm your host here. I'm one of the founders of Kubernetes, and this is a series of live video casts where I start digging into a topic in Kubernetes, and I've done a whole smattering of things. Sometimes it's stuff that I know well that I'll go through and really talk about. Sometimes it's stuff that I've done a little bit of research, and I'll present some of the stuff that I figured out over the past week. Sometimes I did a series where I was doing some live coding of a controller. I thought that was really interesting, really was like, hands on keyboard in an editor type of thing. And, but a lot of what I've been doing lately is taking projects in the community and trying them out for the first time, giving my impressions, trying to put them in context of a lot of the other stuff that we're doing across Kubernetes. I spend a lot of my time these days just trying to keep up with everything that's happening. And a lot of that keeping up means that I only really sort of see the summary of things, or I get to see a demo, but I don't get to play with the stuff myself. This is actually, to some degree, my time where I get to play with something new, dig into it, and you guys can all watch me as I flail around. So hopefully that'll be fun. And so the topic that I'm going to try and cover today, and I did a poll on Twitter, I was looking at a couple of different things, is this thing that's been working for a while called the cluster API. And this is thinking about how, like deploying and provisioning Kubernetes is actually a really tricky problem. And one of the reasons why it's such a tricky problem is there's so much diversity across the different ways that you can deploy it and the different ways that you want to manage the life cycle. And one of the things that we've been doing over time is trying to find more and more ways to build reusable building blocks that build a toolkit that'll actually be usable from a whole bunch of different situations. So let me say some hi. So we have Fabio from Portugal. We have Joseph Heck, who's just down the street here in Seattle. Antoine, nice to see you. Mateus from Brazil. Fernando from Brazil. Are you guys sitting next to each other, or do we have two independent folks from Brazil? And then Dan is in Phoenix. All right, good to see y'all. So one of the other things that I also try and do during these things is do a little review of what's new in Kubernetes land over the last week. And I usually try and do a little bit of prep and think about sort of what have people been talking about. And I didn't do it this week, so I'm trying to rack my brain. I was still recovering a little bit at the earlier end of the week. What's new in Kubernetes this week? Is there stuff that you all have seen that you have questions about? In my mind, things have been relatively quiet. There haven't been a lot of new projects that I've seen folks announce or new interesting. Oh, you know what? I think there was. Let's see. Let me pull it up off screen here. There was. Somebody did mention an interesting looking serverless thing. And let me see if I can find out where that was. It was somewhere in my Twitter mentions here. Let me see if I can dig that up. But yeah, there was a new entry into the sort of serverless space, and I think Kelsey tweeted about it, and it looked really interesting, and so I wanted to play with that. Yeah, I think it was Nucleo, right? So that might be something to do as another topic sometime. See if this, I don't know. Yeah, here we go. Yeah, it's Nucleo. And let me pull this up here. And I'll, again, like I said, I think Kelsey tweeted about it, which is really interesting. And it's a serverless platform, but I think that there's a tilt on this, around event and data processing, which I think is really interesting. I think what we're starting to see is that there's a whole bunch of different ways that people view serverless stuff. Sometimes it's like live functions. Sometimes there's this point of view that everything comes in through sort of a message queue. And so really it's a message queue servicing thing. And so they'll try and squeeze like sort of an HTTP call in through a message queue. I think using it for essentially highly parallelizable things like data processing type of stuff is really interesting also. We start looking at systems like Brigade, and in some ways that's serverless because you have essentially, a piece of code where it's really easy to say, here's my code, and it reacts to events and stuff like that, which I think is really interesting too. So there's all sorts of cool ways of thinking about this stuff. And so, yeah, so I want to, Nucleo stuff looks really interesting. I'll definitely include a link here in the show notes so that you can all check it out. But this might be something that I want to do a TGIK on at some point soon. Looks really, really cool. And I think, as I look at these things, one of the things that I think, my criteria is how well does this integrate with the Kubernetes way of doing things? Does it totally float on top of Kubernetes, or does it integrate in a way where you can start taking advantage of the security protections built into Kubernetes, service accounts, and essentially make it part of a whole? And from my point of view, these things are a lot more interesting when you think about them of how do they actually play a piece of a larger platform. So Steve-O says the CNCF serverless working group is trying to define serverless. I think that's a useful thing, but I think so many times people get together and they try and define this stuff. And I think the devil's in the details. It's better off to just sort of build examples, and then we can extract an understanding over time. Because I think a lot of folks, when they say serverless, they think function as a service, but then we have serverless databases, and I don't even know what the thing means anymore. But from my point of view is that serverless stuff is only as interesting as the framework that it fits inside of. And so if something integrates in a deep way with Kubernetes, that means that it can start taking advantage of other stuff that runs on top of Kubernetes. It can be part of a larger platform. For me, that's super duper interesting. Versus being something that can just execute functions in its own little sort of sort of silo, right? So that's something that I'd be looking at pretty closely as I start looking at this. But maybe we'll save this for a TGIK. Maybe next week we'll take a look into that. So that's one interesting thing that I saw come up. Are there other interesting Kubernetes stuff that you guys would like to talk about? Go ahead. Otherwise, we'll just jump right in. We have Luke from Lower Queen Anne here in Seattle. And then Jason, good to see you in North Carolina. All right. Well, all right, if that's that, what I do want to call attention to is I'm going to go a little bit of how the Kubernetes project is structured. I think one of the things that we're struggling with the Kubernetes project is how do we make the project itself more accessible to more people. And so the stuff that I'm about to say shouldn't have to be said. We should have good documentation, a good sort of contributor guide on this. It's something that we're working on. But generally, the way that we've structured the Kubernetes sort of community is that there's really sort of three types of groups that people get involved in. There's committees, SIGs, and working groups. So a committee is a select set of people, usually appointed or elected, and the idea is that they have to deal with sensitive stuff so they can have closed meetings, and it's usually a more serious type of thing. And so the committees that we that, types of things that might be committees, and we don't have these things all fleshed out as much as we should. But the steering committee is definitely one of those. There's things around security where there's a need for responsible disclosure, and then stuff like code of conduct where obviously we want to make sure that we keep things private and appropriate wherever possible. So we want to minimize the amount of committees inside of Kubernetes because we want to be as open and welcoming as possible. The next type of group is SIGs, special interest groups. SIGs are a group of people that are chartered to essentially take responsibility for a part of the project. And at the end of the day, this group of people goes ahead and owns some code, owns some artifacts, owns some deliverables. And so this is an ongoing ownership over time. And this is where the bulk of the work gets done around design and checking in code and improving stuff. And so that all happens via SIGs. And we have a whole bunch of different SIGs. So if you go to the community repo here, let's see, there is siglist.metadata. And again, we need to do a better way of making this stuff discoverable. Yay, cluster API. I think that Heptio thing there, I think that's Chris Nova, who's logged in as Heptio. So she's speaking for me there. And so you can look at the SIGs here. We have a whole bunch of different SIGs that sort of break up the project across a bunch of different things. But then sometimes there's things that we want to talk about that start crossing SIGs, and then we have this idea of working groups. And working groups are essentially just a structured way for people to have conversations that will cut across a bunch of different things. And so one of the working groups, and usually the working groups are associated with different SIGs. One of the working groups we have here is the Cluster API working group. And, oh, Chris, you still say it says Microsoft here next to your name. Chris joined us a week or two ago. So, or actually, no, Chris joined us a while ago. It was right before KubeCon is when she joined us, or right before reInvent. But the idea is that it's just a structured way for folks to get together and talk about a specific topic. So coming out of cluster lifecycle, which is the SIG that deals with how do we make Kubernetes more manageable from a sort of cluster operator point of view. And the main tool, among other things, that comes out of cluster lifecycle is kubeadm. So one of the efforts to sort of shoot off of that is this cluster API working group. And the idea here is the idea with kubeadm was to, the idea with kubeadm is that it's assuming you have a set of machines. How do you get a cluster installed at that point? Right, so that and not solving the whole problem, but just sort of starting at the point where you assume you have a set of machines, actually makes the kubeadm tool set that much more applicable across a whole bunch of different scenarios. And so I think that's been a successful way to break it down. The cluster API working group is looking at how can we actually get to the point where you have a set of machines. And it's looking at how can we do that in a way that reuses a lot of the patterns that we already have in Kubernetes. And so we'll get into some brass tacks there, but there's some really interesting things that fall out of this once we start thinking about managing a Kubernetes cluster like we manage other objects in Kubernetes. So it's a little bit of noodle baking, but we'll get into it a little bit. Now, so this is the working group that is playing around with some of those ideas. All this stuff is super very early. I don't think any of this stuff, and Robbie, correct me if I'm wrong, I don't think any of this stuff is ready for prime time yet, but hopefully it'll give you an idea of the directions that some of this stuff is going. So associated with this, there's this repo called Kubernetes/kube-deploy. And like a lot of early efforts in Kubernetes, this is kind of a grab bag repo. There's a couple of different sort of sub projects in here, and it's really just an interesting, a place for code to sit while people noodle on it. This stuff is still very early on. One of the things that we're talking about in sort of SIG architecture in the working group is that we may go through and for repos like this, make it clear that they're associated with a SIG versus being sort of a product that's ready for prime time type of thing. Let's see, so Fernando, let me read this comment that you just, something that I believe would be invaluable for Kubernetes is something like Frances just for Funk 17 contributing to the Go project where he shows all the ins and outs of contributing Go. That you are totally right, Fernando. That's something that we're working on. In fact, George, who's works here for Heptio, is part of the Contribax group, the contributor experience. is looking at how do we provide more resources for onboarding people into Kubernetes. And some of this is providing guides and really sort of saying this stuff that people don't say. Some of it is that it really is just too hard. There's a lot of inconsistency. There's a lot of stuff that's not written down, or if it is written down, it's like a pile of markdown that's spread across a whole bunch of different repos. And so there's a certain amount of sort of getting our act in order that we have to do also along this stuff. So it's definitely something we need to do a better job of. So I'm glad to hear you say that. Oh, and then look, and then Chris is saying that back here at the community repo, she has a pull request that I can merge right now to fix things up. Let's just go ahead and do that. All right, so we're gonna do a little, we're gonna do it. So, okay, here we have, all right, so actually it was Robbie that just did this. Oh wait, we have two of them. Did both Robbie? Oh, we have competing ones going on here. So what did Chris do? So Chris went in and she just changed this, but this is a generated file. See here, it says this is an auto-generated file. Chris did not read the instructions. So I'm gonna say, sorry. Oh wait, where'd my keyboard go? Sorry, Chris. This is generated from sigs.yaml. Robbie has you beat. So we'll go ahead and we'll close and comment that. And then we can go through, and if we look at Robbie's flow here. So Robbie, what he did is he went through and he modified sigs.yaml, which is a YAML file that specifies like all the sigs. And then when you generate that, it generates a bunch of sort of readable tables and stuff like that. So this is looking good. And so one of the things that is, I think, as people are contributing to Kubernetes is a little bit confusing here, is that there's this whole idea around, what we found is that for a variety of reasons, the built-in stuff built into GitHub doesn't scale. Yeah, I know we didn't used to have to do this, Chris, but now it's more regular, and it's gonna get even better over time. But we found that the mechanisms around GitHub haven't scaled to the size of the project, and some of this is that we have this really big repo and we want to sort of subdivide it. And so there's this Kubernetes. There's a couple of Kubernetes bots that actually help you do this stuff. Oh, and then and it'll do things like run CI tests and stuff like that. So Pratik, is this info available for the auto-generated stuff? Yeah, so this is the type of thing where if you look at these files, they'll say, hey, look at this README file, and that tells you how to actually regenerate this stuff. But then we can go through in here, and this ran a test, and we actually had something happened. There's a merge conflict with sig list. So there's a conflict that needs to get done there. But what I can do here is I can, if Robbie goes through and does an update and does a rebase, then I can go ahead and fix this. And then what I can do is I can go /lgtm. And this tells the robot, hey, this looks good to me. Once everything lines up, then it'll go ahead and do a merge. I believe what will happen here is that LGTM label will get removed when Robbie does a rebase. But these types of things are like whenever you submit a PR or a bug to Kubernetes repos that have this stuff turned on, we end up with, it starts putting comments and the robot starts interacting, and there's some links here to information about the different types of commands that the robots understand. And so this is a way for us to have our own policy about how things merge and use robots to automate that stuff. All right, so that was like, Chris is going to beat him to a third PR. Okay, Luke says, what does it mean for kube-deploy and kube-anywhere to be in the Kubernetes org, but kube-spray in the Kubernetes incubator org? So that's a really good question, Luke, and this is something that we've struggled with quite a bit. A lot of times people, and what we've seen is, and I don't want to name names here, but a lot of projects want to be in the Kubernetes organization because there's this sort of stamp of approval from the Kubernetes project that's implied when you're an official Kubernetes project. And in me personally, and I think as we've sort of seen how this plays out, a lot of folks are really uncomfortable with this. We don't want Kubernetes to grow to encompass everything, right? And we really have to put limits in terms of what type of stuff is officially part of Kubernetes versus not part of Kubernetes. And so we're trying to crisp this stuff up. So we had the incubator process before. There was an assumption by a lot of folks that if you're an incubator and you sort of check all these boxes, then automatically you graduate into a full project. And we didn't have a lot of good controls in terms of what we let into the incubator process versus not. So we put a freeze on the incubator graduation stuff. Meanwhile, there's sort of a smattering of projects that did get in. There's projects that started before we had the incubator process, so they're in and they kind of got grandfathered in some ways. And so it's kind of a little bit of a mess right now. So the first thing we're doing, and this is happening from the steering committee, now that we have a governing body that's actually here, is we're trying to decide what do we want to do moving forward. And so there's a proposal that Brendan Burns wrote that I think is going to go out widely this week, I think, where we're looking at like probably 3 different types of projects that'll be associated with Kubernetes moving forward. And there's some questions that we have to answer. There's what we're going to call associated projects. And associated projects are really sort of the more traditional contrib type of thing, where it's like, hey, it's somebody who wants to be part of the ecosystem. They want to utilize some of the Kubernetes tooling. What tooling and how they activate that is still to be determined. The big one there is the CLA, which is essentially the bot that helps you deal with copyright. And as we do that, that actually ends up helping smooth the transition as these things may want to move deeper into the Kubernetes world, or it helps to create some sort of shared ground that folks from different companies can actually go ahead and start operating on. So this idea of a loosely associated project with no real sort of stamp of approval by anything official inside of Kubernetes. The next class of project that we're looking at is essentially a sub-project that's sponsored by a SIG. And so this would be marked clearly saying that, hey, this SIG thought this was interesting, they're chartering this project, but the endorsement only goes as far as that SIG, and then it's up to SIGs to decide what makes sense for them and what doesn't make sense for them. The question there, though, is that like different SIGs will have different bars for this stuff, but this definitely is to have, like, let's as an example, there's this project that's associated with SIG scheduling called the rescheduler. And so this is the idea that if you have a bunch of stuff scheduled in your cluster, but if you move some stuff around, you can actually have more efficient packing. If you think about sort of that Tetris analogy, this is like picking up some pieces and moving them around in order to be able to get tighter packing. That's a project that sits outside of the core because it uses public APIs to drive stuff. It's definitely part of the Kubernetes project, but it's not mature enough that we're going to actually say it's part of the regular Kubernetes release. And then the third category is stuff that really is a core part of Kubernetes, which is really, shipped with the Kubernetes release. And so those are the 3 types of projects that we're proposing to think about. Now, this is for going forward in terms of what does this mean for existing projects that are in incubator or have graduated. That's something that we're still going to have to go ahead and figure out. So hopefully that Luke, that answers your question there. Yeah, I'm totally on a tangent on this stuff. We haven't even started looking at this stuff here. Okay. So now let's see. So Jacob went through and LGTM'd after Robbie went through and rebased his thing. Now we see we have 3 checks. We have the CLA that says the copyright stuff looks good on all of this stuff. The CI system said everything was look good. And then there's a system called Tide, which I believe will do an auto merge on this stuff. So it actually runs the integration test one more time. And then goes up. What happened? Let's see. Let me do a. And then it's the robot that goes in and actually does the final merge for this stuff. So yeah, so we just got a live sort of like flow of how PR works in Kubernetes. This is in our community repo, which is really sort of documentation, more informational. One of the things that I'm going to be working with the Contribax folks to do, and we're going to look at, is can we turn this into a website that gets hosted at community.cates.io, something like that, which is instead of sort of a Kubernetes user-facing site, it'll be something that'll be really the homepage for folks that are contributing, going like, how do I contribute? What is happening? Like, hey, what's the state of the release? What do the dates look like? What are the topics for the next sort of, meeting? So that's some of the stuff that we're looking at. All right, now Chris saying that, there was some other updates that Chris wants to get done. All right, Chris, we'll take this offline because I do want to start digging into what's happening here. All right, so so that's a long-winded way to say that we have the Cluster API working group that is digging into this stuff. And, is Jacob no longer super involved in it? So it's just Chris and Robbie. Okay, so let's look at the kube-deploy stuff. So there's 2 directories here that are interesting. There's the cluster API, and then there's, which is really sort of more pure API stuff. Oh, is he on Istio now? Okay. So Jacob's now over on Istio. So the cluster API stuff, and which is like sort of pure API definition type of stuff. And then there's the GCP stuff, which is, I believe, a reference implementation or a starting implementation. So a lot of times when you're developing an API, you have this platonic ideal in your mind of what an API should look like, but it's really very difficult to be successful unless you actually have an implementation or perhaps even multiple implementations that run with that API at the same time so that you can actually test stuff. And so in terms of multiple implementations, I know that Kubicorn, which is another project that Chris has been running, I know Chris was saying that there's a PR to actually have Kubicorn start supporting the cluster API also. And so we'll start seeing multiple independent implementations of that API as it matures, which is really interesting. Kube-orn. Okay, yeah. So Chris always, nothing is ever simple for Chris. She always makes things complicated. All right, so what we're going to do is the Kubicorn stuff is super brand new, hot off the presses. So we're going to stick with the cluster API GCP thing here. But we're going to dig into what the API itself looks like. So Antoine will Kubicorn support Azure? I don't know. Chris, you can maybe say in the comments what the plans there are. One of the things, though, if we do this right, is that we may find that there's pieces of this cluster API stuff that work regardless of where you're running. I think some of that stuff ends up in the kube-deploy stuff, the cluster API stuff also. So this, I think the interesting thing here is that we have API cluster v1 alpha 1. And what you'll see is this is like, now if you've ever, okay, so another digression here. If you type Kubernetes API, and this is a pet peeve, but I'm going to just tell you how it is. You go to this API reference here, you click on this, and you get this page, which has a lot of information about the API. I know that, a lot of folks have ended up here, and I think it was Phil who did this work. So this is really interesting. This is auto-generated from the Swagger API definitions that are produced as part of Kubernetes running. But it turns out that most folks who are operating with Kubernetes on a day-to-day basis, they really don't use this stuff directly from here, right? I don't think that this, is as usable as it needs to be yet, unfortunately. And so the core, this is sort of a rendering of the API. The core definition of the API is in Kubernetes. If we look here, let's see if I can find, because this stuff moved around. Staging, source, API. So here's actually the core definition of the API. And so you'll look at stuff like core v1 types.go. This is the real definition. This is the real deal here. And everything really flows from this. And so this is it's written in Go files. This stuff gets compiled in. The Swagger gets generated from that. A bunch of other stuff gets generated from there. But this is the source of truth for what the API really is. And so Kubicorn, not Kubicorn, the cluster API stuff follows that same convention. And so what we see here is that we have a bunch of Go types, but these Go types are the definition of the API. And then from this, some Swagger can be generated, and there's a whole bunch of tools that are built around generating stuff from these things. You can see like Gen Client and Deep Copy and stuff like that. All right. And so what you see here is that now we actually have types that are very much like Kubernetes API types with spec and status and metadata and all that stuff about defining a cluster and then defining machines within that cluster. And so I think the two main objects that are part of the cluster API are the definition of the cluster and the definition of machines that are in the cluster. And then even based on that, and then there's operators that can then go ahead and operate with this stuff. And so if we go back to this cluster API directory, you can see that there's some tools here, some examples of like a machine set tool, right? So this actually lets you start doing things like scaling and machine creation and deletion in a generic way that'll work regardless of which cloud provider you're actually dealing with. But we'll get to that a little bit later. I think this is probably towards the end where we'll see this. All right, so now we can go, and if we go back to kube-deploy, and if we look at the GCP specific one, this is a prototype implementation for the cluster API for GCP, and this is what we're going to be playing with today. I did look that, like, if you look in cloud here, there's a directory called Azure here that Jessica, who I don't know, has like checked in, but like maybe at some point there'll be sort of an Azure implementation in this thing called cluster API GCP. Maybe it should be called Cluster API Prototype. I'm not sure. This is always funny because these things end up sort of getting called after one, then they expand over time. It's not the first time you see that type of pattern happening. All right, so what I'm going to do here is I'm going to follow the instructions. Oh, and look, this is not uncommon also, is that like there was an update to the README here that Robbie did 15 hours ago because he knew I was doing the TGIK. So hopefully everything will work just fine. But I'll be nice, Robbie. If we hit bumps, I'll let you know. All right. So I set up a new GCP project before I got started. And then when you do that, you have to click on the compute engine thing. The leftover directory when you split out the GCP. Okay, so that is not the real deal, but maybe it'll grow at some point. We'll actually see. Okay, and you added some extra stuff that we can test out. So I have a new GCP project. When you create a new project for something like this, you have to click on the Compute Engine tab, and then it goes through and actually sort of creates some extra stuff behind the scenes, and that can take a few minutes. So I already did all that, and I got gcloud set up. So I can do gcloud, compute instances list, and it says I don't have any instances. Maybe, yes. But then I can also go to the Google Cloud Platform. I have a project called TGI Kubernetes, and we can go through and actually see all this, and you can see this is a brand new project with nothing in it. All right, so there we go. And so let's see, where were we? Here we are. Okay, so we need to have a GCP account, and then I need to create a firewall rule to allow, and this, so I'm going to copy and paste this. And I'll tell you what this does. So this says, so the way that firewall rules work in GCP is things are closed by default, and then you can open things up, and you can essentially say which type of traffic you want to allow, which is TCP port 443, where you want to allow the traffic from, 0000/0 says anywhere in the world, and then what you're targeting. Oh, this got cut off. Target. How did that get cut off? But this is target tags is HTTPS server. And when you create instances, VMs in GCP, you can tag them. And this says any VMs that have this tag, this firewall rule will apply to. This also works within the confines of a specific network. And so there's a default network called default that this thing works with. All right, so that's what we did there. So now, as we create VMs, if those VMs have that HTTPS server tag, then we'll be able to talk to them from the outside. And then it says, okay, I want to like clone this into my, okay, so I cloned this. All right, so let's go through. I cloned this here, but we have a Go directory here. Source, and I'm going to close my, okay, I have to clone it in the right place in my Go path. This is when I was doing the Azure function stuff. Source, victorcates.io, and then git clone this stuff. We'll just go ahead and do that. All right. Resolving delta. I don't know what all this stuff means. It's aligning the flux capacitor. Something's happening. I don't know. There we go. Okay. CD kube-deploy. I'll start up VS Code here just so that we have stuff that we can look at. And then, okay, and then I want to CD cluster API GCP. And I want to do go build. And this has all of its dependencies vendored. So, what did I, export go path equals TGIK go. And let's see what happens. We're building. Hopefully, so I've had issues before where when my machine hits a lot of CPU, the YouTube streaming stuff starts to actually drop. In fact, it's dropped. So let's hope that's not the case. All right. So stuff happens. What do we have? We have now this thing called cluster API GCP here. So we have a binary. So that's exciting. And then creating a cluster. Follow the above steps to clone the repository and build the tool. And then update machines.yaml to give your preferred GCP project zone in each machine's provider config. So this is what's really interesting, is that this stuff is all driven from YAML. And so let's see what we have here. Okay, so interesting is that this is using the generated name stuff that I talked about last week, which I think is an underappreciated feature of Kubernetes API stuff. Now, one of the interesting things here, and I don't know, like this is something that I think is honestly a struggle, is there's this attribute here called provider config, and provider config is a string, and inside that string, there's some JSON. So we've seen this pattern repeat itself multiple times across Kubernetes, and what ends up happening is we want to provide a way to include information in a structured way, and so we've seen it with annotations in a lot of places. But we don't want to sort of bloat the API with all sorts of implementation-specific things. So the stuff inside of here is, because it's in JSON, it's not officially part of the cluster API, but it's essentially hints and necessary information for stuff that's going to be using the cluster API. So it ends up being a pass-through type of thing. Another example where we see this is like with ingress annotations. You'll see a whole bunch of annotations which are essentially pass-through hints to the underlying implementation for that ingress controller. So that's not ideal. It's not actually a great thing, just because like there's nothing making sure that this is actually good JSON, right? So I could make a classic mistake, like add a comma here, and I wouldn't find out about that until a lot later when this thing gets parsed, right? So yeah, so this is actually something that like we don't have a good solution for right now. All right, but this says this is the type of provider that I'm using here. The project here is TGI Kubernetes. I probably want to change that. And then if I look at gcloud config configurations describe, Oh, what did I? If I look at what I have here. All right, so my default zone that I picked was US West 1C. So we'll go ahead and we'll look at that. Gcloud config list. The Gcloud config, I love, so Gcloud config is not bad. I just didn't want to dump secrets on accident, Robbie. Yeah, so there we go. So it's not bad, but like I always laugh when it's Gcloud config configurations. It's like there's kind of some alliteration there, but it's sort of it's ways of switching different contexts here. So machine type is N1 standard 2, which is a 2 CPU with like about 3.5, 4 gigs per CPU. And then the image. So one of the interesting things for those who aren't super familiar with GCP is that GCP has this idea of image families. So quick digressions here. This is like everything that's wrong with AWS in one site. AWS, Ubuntu, AMI. So the fact that this site actually exists is just awful. Have you all seen this? So what this is essentially saying, like, depending on the zone that you're in and the version of Ubuntu that you want and the architecture and whether you're doing, HVM or EBS or whatever, here's the AMI that you want to use for this stuff. And these things change all the time. And anybody who's tried to figure out, hey, I want to launch an Ubuntu image, which AMI do I want to use, has gone to a site like this or has had to deal with this. It's a total pain in the butt. It's awful. The way that GCP works is that number one is that machine images are global, and so you don't have to do this like a regional replication. Oh, you saw the wardroom stuff. So you don't have to do this global replication of stuff, which is super nice right then and there. So that sort of eliminates the zone entry out of this stuff. And then the next thing is there's this idea of image tracks where you can say, hey, I want the latest Ubuntu. And so that means that when you launch, you get the latest thing. And so in some ways, it's like when you do apt-get install MySQL, you're going to get the latest version of MySQL. It's similar to that. You can lock it down to a specific version if you want predictability. But if you just want to be able to write some instructions that say grab the latest Ubuntu, that's super easy to do with GCP. So essentially, okay, so that's a digression there. I apologize, but that's like one of the things that as I've been working with AWS more and more, I've missed having that. Let's see. So this is essentially saying take the latest Ubuntu 16.04, and let's go through. And then, so this is for the master, and then for the node, the project is the same. It's TGI Kates, and we're going to do it in the same zone, US West 1C. And the same image. And then there's other stuff like the version of the kubelet and the version of the runtime, the name of the runtime and the version that you want. And so all this information gets passed through to controllers. Okay, can one pass all params supported by GCU like preemptible schedule option as part of the GCP machine definition? Yeah, so like what Robbie's saying is that I think that's the idea, but there's a certain amount of plumbing that has to actually be passed through here. So part of that binary that I built has the ability to essentially sort of take that JSON file that's embedded in the YAML and then use that as the parameters for starting stuff up. All right, so I got application D. Okay, so we got what does this do? Okay. The Google Auth library. What is Google Auth library? What does application default login do? All right, we're just going to hit allow here. Okay, so this just authenticates to the Google Cloud SDK. Oh, application default credentials. So I was probably already there. Is that in like extra credentials? allows you to run code on your machine that uses the G-Cloud credentials. Okay. All right, so so that means that we can get the same experience from when we're. I thought that stuff was already buried in the the G-Cloud directory. You didn't have to used to have to run it, but now you do. Okay. Somebody move my cheese. All right, so that's running, and so now I can just go through and I can create this stuff. So I was looking at the code before we got there. And we're missing something. So what this is going to do is going to start up a cluster, and it's going to actually add to or overwrite my kube config that's sitting in tilde.kube/config. So like we have ls tilde.kube config that. It's going to go ahead and overwrite that, and I don't want this messing with my stuff. So I'm going to do cluster API GCP help. And here's your first bug report, Robbie. This flag here is kube-config, kofefe. So there's a mistype there, and so I'm going to set that thing. The other bug report here is that this doesn't support the kube-config command environment variable. And so the way that I manage my kube-configs is I use this Heptio labs. Okay, thanks. This is something that Chuck did, which is a super little helper to actually help you set that environment variable. So there's different ways that people think about managing kube configs. The thing's probably a little bit too cute by far, because you can have multiple kube configs and have them merge, and then within a kube config you have clusters and identities and context, and the context brings together a cluster and identity in a default namespace. And so these things are kind of like their own little mini database type of thing. And the fact that we have a JSON file there that's a database kind of bugs me. And so I don't want to do that. And so I just essentially say each file stands on its own. And so I have a different file per cluster. There's different folks who actually sort of view this stuff in different ways. So what I'm going to do here is I'm going to launch this. And so if I do ktx, cluster API, it says, okay, we're going to be using this thing, kube-config, and I can do eval this, and that's just a helper for setting that, and then you can do some command line sort of prompt magic that actually key off of that also. But we're not going to do that because this thing doesn't support that. But what we can do is, as we run this cluster API, as we run this line here, we're going to do -k, which says here's the kube config, and I'm just going to create something in the local directory called kube-config. All right, so this is going off and doing its thing, and so it's creating the master. Now, one of the things I should mention is that typically folks using the cluster API like this will use kubeadm under the covers. And so this is not a replacement for kubeadm. It actually builds on top of kubeadm. Kubecorn is a similar type of thing, where the idea here is that, kubeadm, once you have a set of machines, kubeadm gets you going from there. Kubecorn and the cluster API and this prototype here are all about how can we get you to the point where you have those machines and then hand off sort of cluster building stuff to kubeadm. So the master is created, and we're waiting for that to come up. Now, one of the things that I was looking through the code here also, let's see, so there's the master. It's running. It's probably installing some stuff. We'll start digging into a little bit of the code here. This is too small. Let me make this bigger for y'all. Oh, yes, this icon down here. What do you think this icon does? It's like a little angle bracket bar thing. It actually makes this thing smaller. I didn't figure that out for the longest time. All right, so here's this thing. And so this is waiting for Kubernetes to come up. And so if we go back to this, it says, well, I can look at kube control get machines and instances list. So we don't have the instances yet. And if I were smarter, I'd have multiple panes and actually be showing this stuff working. But let me go through session. I always this thing has too many too many options, and I am not good at the whole switching. Toolbar, right turn. How do I like? Oh, split horizontally. So we're gonna do that. And go source. See cluster API GCP. Okay. So now what happened here is if I can do export kube config equals server doesn't have a resource machines. Starting the machine controller. We'll do a watch there. So watch is a utility that you can install with Brew on your Mac that will repeat something every so often. So this is running this thing every 2 minutes. All right. So what happened here is this caused a master to come up. So essentially brought up a machine, had that machine called kubeadm init. And then what it's going to do, and this is where things get fascinating, is it's going to bring up this thing called a machine controller. And the machine controller essentially knows how to talk to GCP on your behalf. And so then what you do to start up the nodes, instead of having me call GCE directly and call the API to start up those nodes using something like akin to an auto-scaling group, instead, what we're going to do is we're going to have a CRD where I'm going to write into the Kubernetes cluster saying, hey, I want a machine. And then there's going to be a controller that watches for that. Oh, something happened. Deleting master VM, GCE master test 1. So I don't know. Hey, is that Robbie? Should that be happening? So it's deleting the machine. So something went wrong. All right, we just hit something interesting. Looks like it timed out. Okay. Why would it have timed out? So we're starting the machine controller. The machine controller, is this thing up to date? Because I think I didn't build this. Should I just try running it again, Robbie? Let's try running it again and see what happens. I think it's because you're using an alternate VM, the firewall is closed. What was the error string? It says all I saw was starting the machine controller and then have it go directly to deleting master VM. So I actually didn't, it says waiting for the API server to become healthy, started the machine controller, and then I didn't see any errors actually go through there. Okay, so David's saying it's like, I didn't create a VM. I'm running this all from my local machine using, it says couldn't import the service account key. Where did you see that? Oh, couldn't import service account key credential, error, access to, unable to connect to server, IO timeout. What do you think? What did I do wrong? Should I try it again? Will things work? All right, so let's go through and so it says port 443 is closed. I did run that I did open the firewall, so yeah, kube control get machines. Like, yeah, because the thing got torn down now, so it's totally horked now. Yeah, this thing will time out. Nothing should be firewall. I was able, okay, so let's see. So Robbie says, okay, let's just try running it again. Reset, what's going on here? All right, so we'll go ahead and run this thing again. Oh, that I did run. Okay, so did I have to open 8443? I don't know. I'll open 8443 also. Oh man, my thing's all screwed up here. We'll see what happens. Maybe I can make this work. The terminal's all right, so I'm going to open 8443 also. We do gcloud compute firewall rules list. All right. Well, hell, let's give it a try again, see what happens. Oh, shoot. I hit Control C. Meant to focus down here. Okay, kube control create secret failed. All right, let's see what happens there. Okay, it's possible that it's hard-coded to read the .kube config thing. Okay, so that could be a problem. Let me, all right, so Robbie's saying here that there hasn't been a lot of testing done with alternate config file locations. All right. Well, we can tell by the fact that the flag was misspelled, so there we go. Okay, so you're saying that if I look at the code, if I look at service account .go line 75. Okay, so this thing is calling, okay, it's calling run here. Oh, this is fascinating, to create the secret versus using the client directly. Just because, you know, consing together that secret with a file is probably a pain in the butt. And my guess is that run goes through, creates a command. And the way that this works is that if you want to pass down environment variables through, you probably have to explicitly, well, no, like, okay, I didn't have the environment variable set, and so it didn't actually leak through because I had set this. So this thing should actually go through and pass through the config, kube config that it's actually dealing with. All right, cool. So now it actually may work this time since I set the environment variable, and that actually may write through. So let's actually see what's going on. So this thing still doesn't have a machine type. Now, so there's two schools of thought for controllers. One of them is that the controller should register their own CRD. And another one is that, oh, there we go. Look at that. We got nodes. Okay, so we added the machine. And so now if I do nodes, we have the master. So now what happens is that the machine controller watch for that new machine CRD and is going to go off and actually call the GCP if everything works as well. Should actually go off and call the GCE API to actually create the downstream node. And then once that thing comes up, it'll use kubeadm join to actually join the cluster. So which environment? So okay, so what happened here, just like while this is coming up, is when I first ran it, I did not have kubeconfig set as an environment variable. I only set that in the second window as I brought it up. But I did specify an alternate kubeconfig with the -k flag. It turns out that there's places where that binary shells out to kube control directly. When it shells out to kube control directly, any parent environment variables leak through there, but I didn't set the kubeconfig environment variable, so that thing was looking at the default kubeconfig environment variable versus the one that I passed in -k. The second time around, when I was actually playing with stuff, I did set kubeconfig to actually be the one that we wanted to be in this current directory. And so when I ran it the second time, that environment variable leaked into the kubecontrol run, the kubecontrol command that got shelled out to, and then everything worked. And so what probably, if it's a little bit stinky that this thing's shelling out to kubeconfig directly. Yeah, kubeconfig. It's a little bit smelly that it's doing that, but like that's, I think, probably an acceptable shortcut. But if it does, it should make sure that as much as possible, it takes all the state that it needs and injects it in there. And the big one there is the kubeconfig file that it's using. So it should probably pass that as a command line flag to this thing. All right, so this thing still hasn't come up. Let's see what's going on here. If I go to Compute Engine and I look at VM instances, okay, so the node is there. It's just in a matter of it's still in its process of coming up, perhaps. Yeah, help wanted. If you guys wanna help out, that'd be great. It could be here that something else is getting screwed up based on that kubeconfig being in the wrong place also. So let's see. I still may have things be a little bit misconfigured. So we'll keep our fingers crossed here. I'm sorry I'm going a little bit off script here, Robbie. All right. Oh, the two schools of thoughts with CRD. So option one is that the controller registers the CRD itself, which means that when you launch the controller, you have to launch it with an RBAC policy that gives it permission to create CRDs. And that means that it's not just creating a single CRD, you have to give it permission to manage all CRDs, which is a little bit of scope creep. The alternate school of thought is that it's up to the administrator when they're actually installing that controller for the first time. The administrator then goes ahead and creates the CRD for it. So that means that the operator itself doesn't actually need to do the CRD. And so then Robbie says that we're in the process of switching from CRDs to aggregated APIs. So for a quick primer on that, CRDs, you can essentially tell the Kubernetes API server that you want to expand the set of types, and it'll actually store data for you, and you get to import a bunch, but not all, of the Kubernetes API machinery for free, and it's very easy to have that stuff work. The alternate way of doing this stuff is that when an API call comes in, like a RESTful GET or PUT or delete or whatever, when that comes in, the API server does some of the sort of common stuff like RBAC and some admission controllers and stuff like that. And then instead of handling it locally, it just forwards that onto another server. And then it's up to that other server to actually do whatever it wants with that call. And so there's a heck of a lot more power when you're doing these aggregated API servers, but they're a little bit trickier to install and manage, and they have to have their own storage. And so they're definitely a more serious type of thing when you're doing this stuff. But one of the things I do like is that it's there's different APIs that really, for doing similar things, but there's as you get more serious, there's a trade-off between the capabilities you have and the amount of work that it takes to make that stuff happen. All right, let's see. We still don't have this thing up. That's not good. All right, so one of the things that I think another interesting thing about GCP, and this is me because I started GCE also. One of the interesting about GCE is that the images and everything actually does have some more advanced SSH key management than you'll get with something like AWS. So when you I'll answer that in a second, Steve. When you launch a VM with AWS, you specify the SSH key that you want it to use. If you lose that private key, you're essentially out of luck. You can't log into that machine anymore. What happens with GCE is that it goes through and it has by default, and you can turn it off. There's ways to turn it off. But by default, the standard images on GCE are able to update the set of keys that you accept over time. And with that, you can do things like actually have this SSH button here. And so I can press this SSH button. And it'll automatically go ahead, create a new SSH key, install that into this VM, and then create a web-based SSH connection to that thing. So that's actually really, really useful when you're trying to debug what's going in. And so now I'm sitting here on this node, and I can actually start looking to see what's going on. So Steve's saying is, does kube-deploy do multi-master HA? My guess is not yet. kubeadm does some HA stuff with some elbow grease, right? So one of the things that we're working on is making that stuff be easier. With kubeadm, there's a bunch of sort of trade-offs around security and ease of use that we're working through with kubeadm. Once we sort of have that stuff down pat, my guess is that we're going to see tools like kube-deploy being able to deal with it easier. Let's see, so we'll go large here. All right, so first of all, let's make sure that it still hasn't come up. cd var x log. See if I still remember where all this stuff is. Cloud init output. So this thing is, so cloud init is a standard sort of like startup script thing that's useful in a bunch of different places. Cloud init.log. What is this doing? And there's ways to actually hook this in with custom things, and my guess is that's what's being used here. Still not up, so we're like 10 minutes in. Where is this sitting here? So the VM got created. cd var local, is it local? Cloud, cd scripts. Oh. So none of them there. So maybe this isn't working. Okay. Part of the matter, is it possible to launch node machine definition in different zone and later use cadmin join this to the master? I think this probably should work cross zone as long as the networking is set up appropriately. We have Google users. I don't know where this stuff is right now. Okay, so what would you suggest, Robbie, for debugging this? Let's start looking at some code. So what we've done here is we've gone ahead and we've launched the machine, and then we have this runner here, and this is creating this machine controller. So this is going to watch for the machine CRDs and try and spin up VMs. It's using some standard stuff here around probably the cloud Google stuff, which is GC provisioning, provider config, commands, machine actuator is my guess where this is. So where's the kubeadm log, Robbie? Do you know? Where is that going to show up? I'm not sure exactly. That's what I was going to look at to see. So this thing is going through, and I think it's launching machines. And at some point, it goes through and it tries to SSH in to do some stuff also. So this thing is actually actively SSHing in. This is maybe for update master in place. It should be using startup scripts, though, is my guess. And then we have templates here. Here's the startup scripts that are working. And so this is actually, okay, so this is team to var log startup.log. Okay, so the SSH is only for master upgrades. So, okay, so it failed to connect to the API server. There is no JWS signed token in the cluster config map. Okay, so something wacky's going on here. So we're trying to do a kubeadm join, and it's having problems talking to the server. So if we do curl Okay, so the way that this is, we're in the deep in the balls of kubeadmin. What are we trying to get? V1. I'm doing this wrong. Namespace is. All right, so the way that, all right, this is some confusing stuff here, but the way that this stuff works is that as we try and do kubeadmin join, we assume that we don't have some sort of like S3 type of thing to actually reach stuff to, so we have to talk to the server that's already running. We talk to that server to be able to get stuff, and one of the things we're going to get is this kube config. Part of that kube config is there's a signature here that we can verify with the token that's used in kubeadmin. And so the error that we're getting here, if let's do a tail startup.log. The error that we're getting here is that there's no JWS sign token, that's this thing here, in the cluster info config map for token ID TJJVA. And they're right, because the token here is R918D4. I don't know why this is using an older token. It could have been something that was screwed up or left over because I used the wrong kube config and stuff like that. So I'm going to tear this thing down, and we can generate a token, and you can do that. So we can do kubeadmin tokens. And we can look at the tokens that are on this thing. Oh, we have to, shoot, we need the admin thing. That's not here. So let's, so the token that we were looking for. So we can look at the tokens, but actually we need permissions to be able to see the tokens that are available. And we don't have permissions on this machine yet because we're still bootstrapping stuff. So we're looking for one TJJVA5. What we can do here is if I go back here, I can do kube control get tokens or get secrets namespace equals kube system. And what we have here is bootstrap token. Here's the only bootstrap token that we have. It's R918D4. And so we actually, that token got deleted, or we're using a stale token. Something went wrong across the multiple runs that we did. It's probably because I hit a Control-C or something someplace. So what we're going to do here is I'm going to tear this thing down. What's the best way to tear this down? I apologize. I think I was a little too fast and loose with stuff here. Let me go ahead and exit out of this thing. So what I did is I started it and then I accidentally hit Control-C and then I ran it again, but it already started the master, and I think it actually used a different token across those two runs, and that caused things to get confused. And so probably what we want to do is like if this thing is like creating a master and the master already exists, it should probably error out instead of saying like, hey, everything's good, right? Because if it continues, it'll probably have the different credentials across stuff. Okay, so Luke is asking a question. It's probably not dumb. Work is trying to join to the master, or master is trying to join the worker. Who is the active orchestrator of the join? Now, that's a good question, and this is how kubeadmin works, is that the way that it works is with kubeadmin on the master node, you run kubeadmin init, and that starts up an API server with etcd and all the sort of like, mechanics of running a cluster on a single node. And then what you do is you run kubeadmin join from nodes that you want to have join into those things. And after you run kubeadmin init, you get a command line that you can copy and paste with some tokens, and you can go ahead and call this stuff so that you can have the kubeadmin join actually reach out. So what happens then is that there's using that token, you can establish bidirectional trust between these things. You can create and expire and generate new tokens like that. And then And then that essentially, you trade that token in for long-term credentials that can be rotated over time. And the node then is able to actually bootstrap itself up into the cluster. So that's how this flow is supposed to work. But what happened is that the token that the nodes are using is different from the token that the master is looking for, and that's my fault because I screwed up because I was a little bit too fast and loose with the Control-C here. Deleting the cluster. Okay, so I can just run delete. So let's do cluster A delete. So we'll just go ahead and we'll do that. I'm sorry, Robbie. I'm making your thing look bad. It's all me. I think the thing works. I just screwed up. All right, so this thing hopefully is going through and deleting these nodes. And we haven't gotten to the fun stuff. We're going to keep going. We're going to keep going. Let's keep this thing going. It says IO timeout. So it's trying to actually delete the machines. You know what? I'm just going to go through and we're going to nuke it from space. If I just delete the machines, that'll probably get us most of the way there. Yeah, I'm sorry. I'm going off script here. I'm going to delete these. I think that'll work. We haven't done anything else too crazy yet. It works well if if I don't go off script. Okay. So here's what we're going to do is we're going to do move.kubeconfig to kubeconfig.backup so that I have mine. So now we have a blank kubeconfig there. I can go through and I can do export kubeconfig equals. We'll wait for these masters to actually... Okay, so those things are deleted. I'm going to do this. I'm going to take off the dash kafefe, and it's all going to work now. It's all nice and legal. All right. But we've learned a lot. You always learn stuff when you go off script. All right, so what the really interesting thing for me, I think it's great that this stuff actually brings in, hey Ollie, I think it's great that this stuff actually brings up the master and looks at the full life cycle of the thing. For me, the really interesting thing is that this stuff can be dynamic. This thing can go ahead and if we want to start doing cluster auto scaling now, we can actually do that by essentially having a machine set, which is sort of analogous to a replica set in Kubernetes, but now we have a machine set that it manages replication of machines, which is a really interesting idea because now we're further abstracting ourselves from some of the sort of cloud-specific things like auto-scaling groups. And so that is, that for me is the super interesting stuff. We can start dealing with machines in a generic way and start abstracting some of the cloud-specific, gunk from this stuff and putting it in a box, and that box ends up being like that machine controller. So Luke asks, the join token passed in via work instance metadata. Yeah, typically it is. Typically that join token would be passed in there. And there's actually two modes for kubeadm. You can generate that token yourself and then just sort of do a sort of fire and forget where you bring up the master and the nodes all at the same time. And so there's a lot of examples of doing that. Our Heptio quick start on AWS does something simple. It actually uses a Lambda function to generate a random token. That random token is set into the machine metadata, and then these things can stitch themselves together. Things are slightly more secure if you can introduce some asymmetric crypto, and you can actually have you do a kubeadm init. You get a slightly longer command line that also has essentially a hash of the root certificate, and then you use that for the join. And so I call that the swizzle flow because you're essentially taking information from the master and you're giving that to the nodes. And so that one is slightly more secure, but they're both actually pretty good from a security point of view. All right, so Mateus, all right, have a good night. Yeah. Okay, use case for kubeadm API versus the kube-deploy CRD. The kubeadm API is essentially just a config file for kubeadm, and the idea that we want to actually be structured about the way we think of the input parameters to kubeadm. Kube-deploy with the CRD is actually an active controller. So it's watching for things in the Kubernetes cluster and creating and managing machines that way. And like I said, the really interesting thing in my mind is it takes this idea of, say, like a node set or a machine set from something that's a sort of cloud-specific concept into something that's generic across a whole bunch of clouds. All right, so now we're moving along. We got the CRD, we got that. Okay, so now we can go through and export kube control config equals and watch. Okay, do we have the machines? All right, so we have 2 machines and 1 master. And hopefully this stuff is up and running. And what is the other thing that you told me to watch here? Oh, we can do gcloud compute instances list. But we can do that here by looking at this. How do I make this thing on the side? Yes, so okay, so the node is now being created here. And then after that node comes up, it has its startup script, including the injected token that it'll use to actually join the master. Yeah, if we have multiple windows, you can actually see that machine create turns into instance create, turns into a node join. We can see the machine is here, the node's not there when we go to the UI for the panel. Oh, so hide info. Oh, there we go. Look at that. Now we actually see this thing. Okay. So this thing's still spinning up. We'll give it a few more seconds. So I mentioned the SSH stuff before. I think that's also an interesting thing is that if this controller needs to SSH in, it can generate its own SSH keys that never leave the controller or that the controller can manage itself, and then use the sort of dynamic SSH key generation in GCE to be able to inject that into the machines. And that's something that's obviously a little bit trickier with something like AWS. With AWS, what you'd probably want to do is add that extra SSH key as part of your startup script or something like that. You need to actually go ahead and have, build up that more dynamic way of doing things. Oh, look at that. The node is joined. And it says not ready. And it's not ready because it's still installing its networking probably. Because the first thing you do is you install the machine and then the networking. And I was digging in a little bit, and there's a little bit of smoke and mirrors going on here. I'm not going to embarrass these guys too much. In that cluster thing, there's places where you can specify the sitters, the network ranges for services and for the nodes themselves. Yet when, for the pods, but the thing just uses Weave network. So I don't think these folks have sort of plumbed in the sort of like GCP integrated networking stuff yet. Is the token what's used to auto-approve a TLS cert from the node? Yes, kind of. So what happens is that token is used to authenticate to the API server, and that authentication is very limited, but it's good enough such that the node can go ahead and submit a certificate signing request, a CSR, to the certificate API in the API server. There's another component that has policy that says, okay, these are the CSRs that I want to automatically assign based on who submitted them, based on what they're asking to do. And so it's the thing that goes ahead and signs it. So the token is good enough to authenticate to the master and submit the CSR. It's the tokens, that's the certificate signing controller that actually signs the CSR, or at least approves the CSR, and then the node will actually go ahead and download that and use it. All right, so CIDR, sitter, you can say it either way. I think I generally say CIDR. What did I say earlier, sitter? Oh, Chris is giving me crap. All right, so Ferdinand, late to the party. So kube-deploy uses kubeadm to manage the master and the nodes. Right, exactly. But how would you tap into that API to enable cluster autoscaling per vendor? So the way that you would enable cluster autoscaling, I think this starts getting into the fun stuff here. is let me go through and let's look at that next. So I think we have a working cluster now. And so I can go through and get the machines in the cluster. One of the things I'm going to do, kube control get machines. If I look at the YAML, one of the interesting things that we see here is that we have spec. And we have status, which actually has some information. The status is pretty limited right now. It says ready equals false. Why is it not ready? It says it's ready. So I wonder why the status there says it's not ready. Maybe that's another bug. So yeah, so you can actually see that this is now API driven this way. So let's go through, and it says scaling your cluster. So you can add individual machines to your cluster using kube control apply or create, or we can use the client-side machine set tool. I want to use the client-side machine set tool. And yeah, the interesting part is the node ref. Where's the node ref? The node ref. Okay, yeah, so this essentially is saying this is the node that got created to match up with this machine. And so it creates that pairing between the machine and the node. In the status, yeah. Okay, so now I want to go ahead and I want to do the machine set thing. So if I go to cluster API tools, I can go through and go build. I'll build this puppy. Oh, can't. Oh, export. Go. Wait. Oh, machine set. Right? Yeah. Go build. Chris is a pronunciation troll. Yes, I would say so. That's one of her go-to interactions, is making fun of the way you pronounce stuff. All right, so now we have a binary here called machine set and get set equal node. Oh, look at that. There were machines with the label set equals node. And then let's scale it up to 3 machines. So I go ahead and I can scale it up to 3 machines. Here I see that it added 2 more machines. So this starts to feel like I'm dealing with like a replica set, but I'm dealing with nodes. And then it's going through and it's creating two new machines here, which is super interesting. And so it says I can run the scale command, repeat. If I do it again, nothing happens. I can go up to 4 machines. It creates another one. And then eventually I'll see this thing go to 4 machines. It's idempotent, yes. Because just like the replica set, right? Say I want 3 replicas, make it happen. You're specifying the target size. So yeah, let's see if I go through, let's do a reload on this puppy. Is this thing getting its act together? Yes, so now I have 4 nodes there. Robbie's just trying to run up my bill on GCE. Like our free cloud credits actually expired, so I'm actually paying for this, which is kind of horrifying. Have you heard this thing called cloud privilege? It's when you work for a cloud provider and you get as much cloud usage as you want. It's something that they're like, oh, just spin up more things. So yeah, so it's working. So we got that. Let's wait. These things should come up and we should actually see the nodes come up. Okay, could I kill a node to complete the testing? Yeah, let's do that. So what I'm going to do, I don't know. Robbie, will this work? Will I break it if I go through and kill one of these nodes behind its back? Will it really reconcile? I don't know. Let's wait for it to settle a little bit. And okay, so yeah, so we have another one coming up. Oh, look at that. This is exciting. So yeah, so you can imagine that this is now a primitive that you could build an autoscaler on. What's the other things that I could do? By default, the master and the node machines. Okay, so here's my question, Robbie. If I go through and how do I define a new type of thing? If I wanted to, like, say, launch a node using this thing in a different zone, would I be able to do that? Where does it actually store the template? Does it actually sort of use one of the existing ones as a template? So I'm going to go node equals set equals foo. Okay, problem during scaling, could not find existing machines with the label set equals foo. Okay, so the missing thing in the machine set is that there's no CRD to represent the machine set. And so what it's really doing is kind of this pairwise. It's like picking one of them and says, I guess you want a machine that looks like something that's already in the set, and it's assuming that they're all consistent. The next step to sort of make this thing more real would be to probably create a CRD, which actually stores the template of the machine set, and then turn this into a real controller. And so if I go through, and let's go back to CD cluster API GCP. I'm going to take copy machines.yaml to machines extra.yaml. So we're going to go in here. I'm going to look at machines extra.yaml. We don't need the master one because we're not going to create a master. And then I'm going to launch this in US West 1A. And we're going to make this be an N1 standard 2. Machine set is no longer, okay. More than auto-scaling the cluster, just maintaining the fixed node number, healing, and scale up is actually super useful. Yeah, I totally agree. Okay, so, okay, and then the thing I'm going to do here is show labels. So we can actually see the labels that are going on here. And one of the things that we'll see if we look at the labels. What? Oh, you know what? You know what, Robbie? We got to fix this. This thing is not actually activating the GCE cloud provider. And so it's the GCE cloud provider actually should create labels on the nodes as they're getting created that talks about which zone they're in, which actually would be useful. Okay, but what we'll do instead is we're going to go through and we're going to modify this thing. So we did that. So now I can do a kube control apply, because that's how I roll machines extra. Oh, what I did something wrong. What is it mad about? What did I screw up? Oh, did I? Okay. Oh, I was doing this like, okay, this is as a list. But what we're gonna do is this is just a single thing, not a list. Okay. Kube control, that is not a good error. Error when retrieving. Oh, does apply, what's going on? I'll just do create. All right, there we go. So now we have this new thing. Oh, shoot. I want to do a delete. I forgot to. Oh, which one got created? This one, okay. Kube control, delete. We'll go ahead and delete that thing. What I wanted to do is set equals foo. We want to give this thing a different set. Okay, now it's creating something with set equals foo. Yeah. Hans, you're way ahead of me here. You're totally way ahead of me. Okay, so now if I go to kube-deploy, cluster API, tools, machine set. Now if I go through and scale, and I say I want to scale set equals foo to 3, this now creates 2 more foo sets. So now I actually have 2 sets that I can scale separately. They have different sizes. One's N1 standard 1, one's an N1 standard 2, and then one of them's in one zone, one of them's in another. And I may actually hit some limits in terms of the number of VMs I can start on this brand new project. But if we look at this right, this should go through. Yeah, so now we actually see we have some in US West 1A and some in US West 1C. So that's really cool. Yeah. All right. And so you can imagine that you could use this for doing upgrades and stuff like that, where very much similar to a deployment, where you could have a machine set, and then that machine set could have an idea of the node that you're actually, the kubelet version, say, that you're using, or the image that you're using. If you want to do an upgrade, what you can do is you can create a new machine set with the new thing and actually rotate these things. And so we can build up those layers of machine, and then machine sets, and then probably, you know, machine deployment that sits on top of that or something like that, using the same type of mechanisms. Meanwhile, you could have those things orchestrate the life cycle of those machines, things like marking them as drained, figuring out when they're actually drained so that you can shut them down. Okay, so skip the other, and let's do the repair part. Okay, so yeah, so usually I try and keep these to an hour and a half. We're pretty much out of time, but let's see if we can squeeze in one more thing here because I'm having fun. And that is the node repair. To test node repair, first pick a node, SSH into it, and break it by killing the kubelet process. All right, let's go ahead and do that. Echo node. Yeah. Oh, no, we don't want to do the master. The master is probably not the one that we want to do, right? Oh, it'll always be the master. Let's actually pick the non-master one. What happens if I do the master, dude? Like bad things happen? Okay, so GCE SSH this. Is that in the right zone? No. That's one of the new ones. Let me do one of the old ones because that's in my default zone. So I have GCE alias to gcloud compute because I'm tired of typing it. All right, so now we're SSH'd into this thing. All right, so now we've gone through and this thing is now sick. What we should see at some point is that this thing will go to non-ready. And then we can run the node repair tool. So I'm going to exit out of this. As tools, node repair. Repair, okay. So we have the repair tool. Go build, right? So you can see this thing's not ready. So it's sick. I don't know what's going on here. Yeah, if you want to fix that script, Robbie, you probably want to do the list based on a label selector so that you don't get the master. Because it's in a different machine set. Okay. And now I can do repair, and I want to do dry run true. Okay, so found an unhealthy node, and now it lists all the healthy nodes, and then now I can actually go through, and now let's see what happens when I run it without it. And then it just deletes the node, and then recreates it. So what does it do? Did it delete the machine? So it says deleting the node, but did it delete the machine object and then recreate it? What did the repair actually do? Probably command. Oh, deleting the nodes deletes the machine. Interesting. Okay. And then it says recreating node. Does it recreate? Oh, it recreates it with a new name just because it wants to make sure that so we have FQDD. Okay, we do have FQDD. Okay, so that actually then goes ahead and then you just recreate the whole thing. Okay, so it deletes the machine object, which then deletes the VM, and then it goes through and it recreates the machine object, so it gets recreated. Okay, so it essentially goes through so now let's go through. Let's pick another one here. We're going to pick Q3CC0, and let's go ahead and we'll see. I'm going to take this, and I'm just going to delete this thing out from under it. Let's break our cluster. So it recreated it with the same name. Okay. Yeah. So now we've done this thing. It's being deleted. I wonder if this thing will actually recover. I'm going off script again, Robbie. I'm sorry. All right, so that thing's gone. I haven't updated the, so I wonder, so the question is the machine controller, if it actually deals with the fact that it'll actually do reconcile and recreation. Because that'll happen with like the replica set, right? If you delete a pod, it's up to the, or if the pod dies or whatever, it's up to the replica set to actually create a replacement. So is it too destructive to auto heal? I don't know whether this will work or not. I think this would sit in the machine, in the GCE specific machine controller to actually be able to reconcile this. It just may not be implemented yet, but I think logically this type of auto heal is something that this would take into account. But even regardless, what would happen is if I look at the nodes here, we definitely have that one that I killed out from under it is now not ready. And so I could go through and I could run the repair again, and it'll actually go through and tweak it a little bit. So even if we, having that machine just disappear off the face of the earth is enough to actually have to have that repair daemon come in and actually kick it so it gets repaired also. All right, well, super cool stuff. I think this is really exciting stuff. I love the idea of taking this stuff that is up until now been super cloud specific, the idea of repair, the idea of a machine set, and moving that up into a realm where we're using patterns that are common to Kubernetes. We actually can separate out the cloud specific stuff from the stuff that is common across all the clouds. And so that machine set utility, the repair utility, a lot of the setup and sort of scripts to actually get the thing up in the first place, that stuff will work regardless of which cloud that you're running on. And for me, that's a really, really exciting thing. And so Robbie's saying that if we had the GCE cloud provider configured, one of the things, and this is something that is actually differs between the different cloud providers, is that it can recognize that, hey, if this VM disappears from the cloud provider's view of the world, it then goes ahead and deletes the Kubernetes view of the world. And so this is something that the GCE cloud provider does. I think AWS leaves the node around. So I think that's one of those things that is inconsistent between the different cloud providers. How would this compare at a basic level to Azure AKS? At the end of the day, the most interesting stuff here is about managing the machines themselves. One of the things that you get with GKE, AKS, or EKS as that becomes available is management of the master. You saw that I almost followed Robbie's instructions and actually killed the master. That's the type of thing that probably would have killed this cluster pretty good. If this were running with GKE managing the cluster, then the assumption is that the cloud provider provides a lot of other sort of remediations and self-healing that applies to the master in addition to the nodes. Now, as we get to the point where kubeadm supports HA and we get more levels of self-hosting, it's not unreasonable to think that this will deal with, if we had two masters, if one master goes down, there's enough running on the other master to be able to bring the first master back up and essentially have these things juggle. The only bad problem would be if both masters failed in a catastrophic way at the same time. So I think over time, we're going to see the ability for the self-healing that you get with the cloud provider, things like GKE and EKS and AKS, to be more and more standard across different implementations. The other thing to keep in mind here is that this stuff assumes that you have an API for creating nodes. If you're running on-prem, you can't guarantee that all the time. If you have something like VMware where you can drive the API there, that's definitely something that's interesting. But I think one of the interesting things here is that if you do have an API, this makes it that much easier to provide a GKE-like service on top of that API, regardless of where it's at. And one of the patterns that we see from Heptio is that there are a lot of folks, especially as people start looking at data sovereignty and edge computing, where there's going to be a lot of cloud providers that folks are going to be dealing with across all sorts of different geographies. And so I think there's going to be a lot of folks who, even if they wanted to, couldn't standardize on just one cloud, because the reality of how they need to deploy is really pretty complicated. Okay, so one last question is, so Ferdinand says, how does one automate based on load, i.e. grow and shrink? How about master replication? So master replication needs some support from kubeadm. That support's coming. It's still very early. There's a lot of complicated dealings there with especially how the nodes actually find the masters when you have multiple masters. Generally, you lean on a cloud-specific load balancer to do that. That's very non-standard and makes this stuff harder. In terms of automating based on load and shrinking and growing, there's already the cluster autoscaler that this could play into. There's also, but it definitely follows the pattern of what you see with the horizontal pod autoscaler. So the horizontal pod autoscaler monitors some metrics. Based on those metrics with some dampening because you want to avoid hysteresis, it essentially just goes into a deployment or a replica set or what have you and adjusts the numbers of replicas based on that policy on the signals that it's seen. Similarly, there would be a cluster autoscaling controller that would look at a bunch of the metrics coming out of the cluster and then go ahead and twist the dial in terms of the scale of the number of machines in the machine set controller, something that doesn't exist yet but is hinted at with that sort of client-side machine set utility. And then node labels, will they be preserved on reload? So node labels are actually a really interesting thing. You saw that the machine labels got turned into node labels, I believe is how that worked. Maybe, maybe not. There's actually a lot of security considerations around node labels because they can actually steer where jobs get scheduled. And so in future versions of Kubernetes, there's going to be more limitations on who can set which node labels. And so there will probably be something along the lines of, and I don't know exactly how this flow is coming out, but it'll be something like the node comes up, but it's not in a ready state. And then it's up to the master to go ahead and put the node labels on that, and then the node goes ready at that point. And so that means that somebody with permission is the one who's actually applying the labels. Another thing that we could do, and we have to think about it, is somehow embed labels into that bootstrap token so that certain types of tokens imply that you get to set certain types of labels, or you must set certain labels on your node as it actually comes up. But it's definitely something that is still being developed in terms of how exactly node labels get set in a reliable and a secure way. All right. So thank you, everybody, for joining me and all the great questions. And thank you, Robbie, for all the hard work on a super interesting project and for dealing with me as I went off script. Really, really cool stuff. I'm really going to be keeping an eye on where this stuff is going. And I'm looking forward to seeing more independent implementations and things like Kubicorn. So super duper cool. And thanks for joining me. Tune in next week. Hit the subscribe button. It'll let you know when new things are coming. And I think I might do the Nucleo stuff next week. I think that might be fun. So, all right. I'll talk to you all later. Thanks for joining me.